Welcome all. In this lecture, we can discuss about impedance and AC power. So, impedance can be defined as a ratio of voltage phasor to current phasor. So, since voltage and current are phasors, impedance will be also a complex number. So, firstly, we can discuss about the impedance of a pure resistive circuit. So, for a pure resistive circuit, we know that the voltage and current phases are in phase. Means V is equal to V angle 0 and I is equal to V by R angle 0, where V is the RMS voltage and V by R is the RMS current. Angle is 0. So, according to the definition of impedance, Z is equal to V by I. So, since V and I are vectors or complex numbers, Z will be also a complex number. So, for a resistance, V is equal to V angle 0, I equal to V by R angle 0. So, we can substitute here. So, and this V will be cancelled, become R. Means for a resistive circuit, Z is having only real part. Z is a complex number, but for a resistor circuit, Z equal to R. Means it is only a real part only. The imaginary part will be 0. Then for an inductive circuit, we have voltage is current is lagging the voltage by 90 degree. Means voltage V equal to V angle 0 and vector I equal to V by XL angle minus 90, where XL equal to inductive reactance omega L. So we can find the impedance Z equal to V by I. V is V angle 0, I is V by XL angle minus 90. So again this V will be cancelled, so it become XL angle 90. So if we are converting this is in the polar form, magnitude and angle. So if we are converting into rectangular form, A plus JB form, it will be XL cos 90 will be real part and JXL sin 90 will be the imaginary part. So cos 90 is 0, sin 90 is 1. So this becomes 0. So it will become JXL. Means if the circuit is purely inductive, if it is only inductance is present, Z will be having only imaginary part, JXL. XL is the imaginary part. Then for capacitive circuit, the phasor diagram is like this. Current is leading the voltage by 90 degree. V is equal to V angle 0 and I equal to V by XC. XC is the capacitive reactance 1 by omega C. So again Z equal to V by I, substituting V angle 0 by V angle XC angle 90. So it become XC angle minus 90. This become minus 90, 0 minus 90. So minus 90. So if you are converting it into rectangular form, XC cos minus 90 plus JXC sin minus 90. Since cos 90 is 0, this term becomes 0 and sin minus 90 is minus 1. Okay, sin minus 90 is minus sin 90, it is minus 1. So minus JXC. Okay. So in capacitive circuit also the Z is having only imaginary part, but it is negative. So we can conclude that for a resistance, Z is R, purely real part only, and for inductance Z is JXL, only imaginary part, but it is positive. And capacitance, Z is purely capacitive circuit, Z is minus JXC, purely imaginary, but it is negative. So this is the condition for purely resistance, purely inductance and purely capacitance. So in general, means the combination of these three, if there is R, L and C in the AC circuit, it will be the combination of these three, means it will be having real part and imaginary part. So real part will be R, resistance only, imaginary part will be XL minus XC. Okay, so we can say in general, if it is a combination of R, L and C, so that is the circuit. In practical circuit, there will be resistance, inductance and capacitance in general. So Z equal to R plus J XL minus X. There will be real part and imaginary part. Imaginary part will be the difference of inductive reactance and capacitive reactance. inductive reactance will be positive and capacitive reactance will be negative. So we can term this XL minus XC as X, where XL minus XC is equal to X. So this is the general form of impedance. Z is equal to R plus Jx. The impedance will be a complex number and will be having a real part and a imaginary part. The real part of Z will be resistance of the circuit, and imaginary part of the X will be X, that is the reactance, will be reactance. Again, reactance will be the combination of these two, inductance and capacitance, XL minus XC. And again, if the imaginary part is positive, if this is positive means XL is greater, means the circuit is inductive. So we can again, if imaginary part is negative means XC will be more, XC will be more than XL, so it will be capacitive. Means we can easily find the whether the circuit is inductive or capacitance looking to the impedance. If it is imaginary part is positive, it will be inductive. If it is negative, it will be capacitive. Again, we have Z equal to R plus Jx. This is the general form of Z. So we are generally representing the Z in the rectangular form, real part plus J imaginary part, like that. So if you are converting this into polar form, it will be the magnitude will be the magnitude of this root of R square plus X square, and angle will be tan inverse X by R. Again, if we are considering a general circuit phasor diagram, there will be a voltage and there will be a current. The angle between will be phi. So voltage equal to some magnitude V angle 0, there will be RMS voltage, and I will be the magnitude I, any magnitude, it will be depending upon the impedance or the circuit parameters. Angle minus phi, it is lagging, so minus phi. So from this, by general equation, Z is equal to V by I, we can find the impedance. V by I equal to this V angle 0 divided by I angle minus phi. So it becomes V by I angle phi. Means Z is actually having a magnitude and angle. Z angle theta. Z is the magnitude and angle is theta. So from comparing these two, we can say that the magnitude Z is actually magnitude of Z, that is this small Z is equal to V by I. This is the magnitude, and from this is root of R square plus X square. So magnitude is Z equal to V by I. The ratio of magnitudes, these are the V and I. This is not vector, it is only magnitude. So magnitude of Z is the ratio of V by I, and or we can find from the parameters as root of R square plus X square. And angle theta is, from this it is phi, means angle between voltage and current, and from this it is tan inverse X by R. So angle of Z is phi or tan inverse X by R. So angle of Z is, we can find from voltage and current, it is the angle between voltage and current vector, or it is the tan inverse of X by R. Okay, so some circuit parameters, tan inverse X by R. So again, so we can find Z in either ways, V by I angle phi or root of R square plus X square, angle is tan inverse X by R. So if you want to only find the magnitude, we can easily find like this. Okay. Anyway, so if we found that phi is equal to tan inverse X by R, or we can say that tan phi, it should be noted that the phi is the angle between voltage and current, phase angle. Okay. So phi is equal to tan inverse X by R. It is the angle of Z also. Okay. Anyway, this tan inverse X by R equal to phi means tan phi is equal to X by R. Okay, tan phi equal to X by R. So if by looking to this equation, we can say that if tan phi is X by R, we can consider a right triangle having the opposite side as X and adjacent side as R. So it will be the triangle phi. By looking to the trigonometric equation, we can convert this equation to a geometric form as a triangle with adjacent side R and opposite side as X. So if you are we know R and X, we can easily find Z. This side, this will be equal to root of R square plus X square by Pythagoras theorem. But root of R square plus X square is the magnitude Z. So this side will be Z. Means if you are considering a right triangle, the adjacent side is resistance, the opposite side is reactance of the circuit, and this is the impedance, magnitude of impedance. All are magnitudes. Okay. So this is called impedance triangle. So impedance triangle means there is a right triangle with the angle phi. Phi is the angle between V and I, or angle of the impedance also. And the opposite side is X, reactance of the circuit. Adjacent side is the R, resistance of the circuit, and Z is the magnitude of the impedance. So that is about impedance. Then we can next go to the power, average power. So before average power, let us consider a AC voltage Vm sin omega t. Then generally current will be having a magnitude Im sin omega t, some angle with the voltage. It can be either positive or negative according to the nature. If it is inductive, it will be minus. It will be, if it is capacitive, it will be plus. Okay. Anyhow, this is the voltage and current. Then we can, before going to average power, we can find the instantaneous power. Instantaneous power means the changing, it will be changing at every instant. It will be equal to just V into I, the product of instantaneous voltage and instantaneous current. This is the instantaneous power. So we can substitute for V and I. V is equal to Vm sin omega t and I equal to Im sin omega t minus phi. So again we can multiply this. So Vm Im sin omega t into sin omega t minus phi. Again we can apply this sin A minus B. Okay, sin A minus B is equal to sin A cos B minus cos A sin B. Okay, so it become like this. So sin omega t minus phi, we can apply sin A minus B, sin A cos B minus cos A sin B. Again we can multiply this sin omega t into sin omega t sin square omega t, and here sin omega t cos omega t sin phi. Okay, so it become like this. We can multiply this with these two. So again this becomes sin omega t cos omega t. It is in the form sin A cos A. So we have sin 2A is equal to 2 sin A cos A. So by using this we can write as sin 2 omega t by 2. So it will be like this. So this is the equation for instantaneous power. So we have instantaneous power is equal to Vm Im sin square omega t cos phi plus sin 2 omega t by 2 sin phi. So if we have the average power, if we have the instantaneous power, this is the instantaneous power, we can find the average power by integrating over a time period. So here time period is 2 pi. So we can integrate 1 by 2 pi integral 0 to 2 pi. So it will be give the average power. We can integrate this instantaneous power P by time period over a time period. So here the AC waveform is having a time period, sine wave is having a time period 0 to 2 pi. So 1 by t, 0 integral 0 to t. That is the equation for average, finding average. So we can substitute for P. Vm Im sin square omega t cos phi plus sin 2 omega t by 2 sin phi. Again we can so again we can substitute. So we can take Vm Im cos phi. We can split into these two. Okay, first term. So 1 by 2 pi this Vm Im. So Vm Im cos phi is constant. Vm Im cos phi is constant. We are integrating with respect to d omega t, with respect to omega t. So cos phi is constant, phi is constant, Vm Im is constant. So for first term Vm Im cos phi by 2 pi, and this only sin square omega t, d omega t. And second term Vm Im, then 2 pi, this 2 sin phi, this is constant. So Vm Im, this sin phi, 2 pi into 2, 4 pi. Only we have to integrate sin 2 omega t only. Again for integrating we have to convert this sin square omega t. So it become, we can use the formula 1 minus cos 2 omega t is equal to 2 sin square omega t. So converting the sin square omega t to 1 minus cos 2 omega t by 2. So we can integrate now. So integral of this term is, we can take 2 is constant, so 4 pi become 4 pi, and integral of 1 is omega t minus cos 2 omega t. Integral of cos 2 omega t is sin 2 omega t by 2, and the limits are 0 and 2 pi. For this term integral sine to omega t, it is minus, integral sign is minus, so minus cos to omega t divided by differential of this. So 2 limits are 0 and 2 pi. So if you are looking here, if you are applying the limits, this term become 2 pi minus 0, so that is 2 pi, and this term sine 2 pi is, so sine 4 pi is 0, sine 0 is 0, so this term will be having only this 2 pi. And for this term cos 4 pi is 1, cos 0 is 1, so 1 minus 1 0, so this term becomes 0, and here only 2 pi is there. So the answer is VMIM cos phi by 4 pi into 2 pi, and it becomes 2 pi by 4 pi 1 by 2. Okay, so VMIM cos phi by 2. So 2 is actually root 2 into root 2, so we can write as Vm by root 2 into Im by root 2 into cos phi. We are splitting this because Vm by root 2 is actually the RMS voltage, VRMS. Im by root 2 is the RMS current. So that's why we are splitting. So we can write average power as Vi cos phi, where V is the Vm by root 2 RMS voltage, I is the Im by root 2 RMS current. So we can say that average power P is equal to Vi cos phi. It is the V and I are the RMS voltage and current, only magnitudes, and phi is the angle between voltage and current. Again, now we can discuss the complex power. So consider V is equal to V angle 0 and I equal to I angle phi for a general circuit. Okay, the voltage between the angle between voltage and current is phi, and magnitude of voltage is V, magnitude of current is I. So let us so power is product of voltage and current, so we can find the complex power. We can multiply this voltage and current. So complex power we are notating by S equal to voltage vector into current vector. If you are multiplying two vectors, it will be either vector S. Okay. So complex power is a complex number, will be voltage and product of voltage and current vectors. So again we can substitute this. So V angle 0 into I angle phi. So we'll be getting as Vi. So we can multiplying V into I, angle is 0 plus phi. Okay. So this is the vector S. Again we can convert this into rectangular form. This is in the polar form. So Vi cos phi plus j into the imaginary part will be magnitude into sine of the angle. So Vi sin phi. So it is having a real part and imaginary part. So if you are looking this real part is actually Vi cos phi. It is actually the average power. Okay, so real part of S is actually Vi cos phi, that is average power. It is also called active power or real power. Then if you are looking, the imaginary part is Vi sin phi. So it is called the, and again the unit of this average power or active power, real power is unit is watt. And if you are looking, the imaginary part is Vi sin phi. So it is actually imaginary part of S equal to Vi sin phi. It is called reactive power and the unit is VAR. Then the magnitude of this S is actually a complex number. P and Q are ordinary numbers, is a real part and imaginary part. So S is a complex number. The magnitude is actually Vi, the product of voltage and current magnitude only. Okay, so that is called magnitude of S is small S equal to Vi. It is called apparent power. So the unit is VA, volt ampere. So these are the powers related to a AC circuit: real power, reactive power, and apparent power. Okay, again, so we have S is actually a complex number with real part and imaginary part. Real part is P and imaginary part is Q. So we can write S equal to P plus JQ. So if you are finding the angle, so angle of S is actually phi. So phi is the angle of S. From this we can find the angle as tan inverse Q by P. So phi is equal to tan inverse Q by P, or tan phi equal to Q by P. So we have the equation tan phi equal to Q by P. From this equation we can geometrically draw a triangle, right triangle with angle phi and opposite side Q and adjacent side P. Okay. So again this hypotenuse will be equal to root of P square plus Q square, but Root of p square plus q square is the magnitude of s. From this equation, root of p square plus q square is the magnitude of s. So it is s. Means if you are considering a right triangle with angle phi, opposite side will be q, that is reactive power, adjacent side will be p, that is the active power, and hypotenuse will be apparent power, s, magnitude of s. Okay, so this is called power triangle. It is similar to impedance triangle, there will be a power triangle. Next is power factor. Power factor is simply the ratio of active power to apparent power. So PF is the P by S, active power by apparent power. So it is equal to VI cos phi by VI. P is VI cos phi, S is VI. So it becomes cos phi. So we can also define power factor as the cosine of phi is actually angle between voltage and current phases. So power factor is the cosine of angle between voltage and current phases. Ratio of active power to apparent power, or cosine of angle between voltage and current phases. Again, if you are considering the impedance triangle, the angle is same, phi. For a power triangle and impedance triangle, angle is same, phi. So from this, cos phi is x by r. So from impedance triangle, we can find power factor as cos phi equal to r by z. Okay, sorry, r by z, adjacent side by hypotenuse, r by z. So we can also find the cos phi by circuit parameters r by z. Again, power factor is power factor is cos phi. So cos, the range of cos is actually 0 to 1. So 0 is power factor will be, the minimum value is 0 and maximum value is 1, unity. Okay. Also, if this phi is positive, it is called leading power factor, and if phi is negative, it is lagging power factor. So this is about power factor, and we can conclude like, for a resistive circuit, phi is 0. So active power will be equal to P equal to VI cos 0 is VI, cos 0 is 1. Reactive power sin phi, sin 0 is 0. So there is no reactive power for resistive circuit, only active power. And power factor is unity, cos 0, 1. It is called unity. So resistance is a unity power factor load, and consumes only active power, no reactive power. For purely inductive circuit, phi is minus 90. So active power is 0, cos 90 is 0, but reactive power is sin 0 VI, so maximum. So only reactive power only, and it is minus, phi is minus, so it is called lagging, cos phi is 0. So 0 lagging load is the inductive load is actually 0 lagging load. And for pure capacitor circuit, phi is plus 90, again P equal to 0, Q equal to VI, and it is plus, phi is plus, so it is leading. So capacitor circuit is a 0 leading power factor load. Okay. So with this we can wind up the session. Thank you.